When it comes to processing and analysing criteria, you have to get what they're actually looking for. Basically, we're saying, can you tell us the story that is hidden in the data? Can you tell us how things changed because of what you did? Can you tell us how that relates to what you've learned about what's actually happening and why? That's what this is all about. So we're going to quickly go over what you have to do at each of these levels in order to achieve a C or above. So to start off with, the very first thing they want you to be able to do is to point out any patterns in your data. In other words, or trends. Pattern is something that repeats over and over again. So every time the sun rises, we noticed an increase in temperature. That's a pattern, okay? And we can measure that scientifically. A trend is where you have something going up or down as you change things. So in this case with our crystals, we were looking at a trend because as we increased the time it took for them to cool down, then we actually saw that the size of the crystal actually increased as well. So that is a trend. Now to get a C in that, this is what you have to do. First of all, you have to describe what you're changing and how it changed. Okay, that's the first bit here, and that has a few little sub-steps I've put here to help you out. How did you change the independent variable? Well, to start off with, here's an example here. We grew them in different temperatures. We had one cool down quickly and we had the other cool down slowly. I have just told the reader how I changed the independent variable. The next thing is, can you tell me the general trend or pattern, in this case trend, that we saw in what we measured, our dependent variable? We noticed that crystal size was larger in the group that cooled down slowly compared to the one that cooled down quickly. I have just told them the trend. It was larger in the slower one compared to the fast one. Next, tell me if these results match the hypothesis. These results match the hypothesis which stated, you've got to go back and say what the hypothesis was, that increasing the cooling time would increase the crystal size. And there I've got it. I have got a C. Now, I've taken that very same one and added it over here and shown you what it looks like as a B level. So to go on top of that, to get a B or an A, we actually have to describe and explain things in a bit more detail. You have to describe in detail how you were changing each of those groups and how they changed compared to each other. In other words, how much bigger or smaller they were. So let me show you what I mean there. I've got exactly the same thing here, but I have added this. The crystal size was larger in the group that cooled down slowly. We said that just over here. We've put here on top of this, the crystals which cooled down slowly were 3 to 4 times larger than those that cooled quickly. In other words, I've described this mathematically so people can start to get a picture in their heads of what it looks like. That's the important thing. And as long as you've got that, you are sitting on a B. If you want to really, you could actually describe that even better than that. I actually put down here, I split it up even further. When you look at the actual graph, the copper and the aluminium were 4 times larger. The sodium was double the size. Okay, so I've actually been a bit more specific. And if I saw something to that level of specificity, I would actually give them a B+, because they can't do any better than that. Last but not least, A level is, can you explain what is happening scientifically? Okay, can you actually relate it back to what we've learnt? So I've literally taken these statements here and I've added in a little bit more. I've actually said here, this result, now here it is here, this result can be explained using, in this case, particle theory. Okay, what's happening with the particles? When in a liquid, the particles are moving around, they cool down and they change into a solid. Crystals are organized solids. Now I've just said why this is important. So we've got a liquid going into a solid. Why is this relevant? Because crystals are organized solids and they need to be neatly packed. Okay, so that is me actually saying straight away there how this is relevant. Now I've actually gone a bit further here and said the more time they have to organize into a pattern, i.e. cooling down slowly, the larger they will grow. Now that is me specifically relating why particle theory is important for what we are seeing here. That is the most important bit. If you actually relate it to that bit there, why is particle theory relevant at all? If you explain that and make that link, then that is a full A there. That link there is the important bit, because you have really explained not only the theory, but why it is important. Make sure you do that. Okay, that is processing and analysing in a nutshell. Give it a go.